Hello everybody. Today we are going to talk about the component method of vector addition. And to solidify our knowledge of this same concept, we are collectively going to solve this problem right on our screen. Without further ado, let's jump right into it. The question reads, 4 coplanar forces act on a body at point O as shown in the figure below. This figure below here. Now it goes on to say find 1. The magnitude of the resultant vector r, 2. Its direction, and 3. Geographically draw the direction of the resultant vector. Now let's begin with the solution to this problem. Right here we're given 4 forces, and I'm going to draw my xy plane. Okay, this might not be too artistic, but let me try to make it better. This is our y plane, and here we have our x plane. Let's now use this to solve this problem together. If you look closely at this image here, you'll discover that there are 4 vectors. How did I get to know the vectors? Just look at the arrows, right? Let me write, here is the positive y axis. This is the positive x axis. Here we have our positive x axis. This is our negative y, and here is our negative x axis. Now, let's copy down the vectors, or let's write them down. The first vector is inclined exactly on the x plane, the positive x axis. If you look at this one here, you can see there is a first vector here, which has an arrow. Okay, this is our first vector, and the magnitude is 80 newtons. That's the first one. The second vector has an arrow this way. If you watch closely, you will see it there. And this vector is inclined at an angle of 45 degrees. This is our second vector. The third vector is on the second quadrant, and then it's also inclined at an angle. This is 30 degrees. And lastly, we have another vector which is found in the third quadrant, and then this vector is also inclined at an angle of 20 degrees. All right, these are 4 vectors, so you must make sure you check out for the arrows. The arrows tell you about the vectors. It tells you, hey, this is a vector, right? Because a vector quantity is a quantity that has both magnitude and direction, and these arrows denote direction. So in order not to get confused, whenever you have such a question, all you need to do is to check the arrows and count the number of arrows given to you in the question. This is our 1, this is 2, 3, and 4. And they actually mean that there are 4 vectors given to us in the problem. Now, let me write their respective magnitudes. This one is 100 newtons. This right here is 110 newtons. And lastly, this is 160 newtons. Okay, now how do we solve this problem? We are going to resolve these vectors into components using trigonometry. If a vector is inclined at an angle, okay, it has components in the y and in the x direction. So this vector, for example, this 100 Newton vector has components in the x and in the y. Why is it so? It is because it is inclined at an angle. And as long as it is at an angle, you must resolve them into components to get the x and the y components respectively. In the same way, this one here, which is 110 newtons, it's also inclined at an angle. So it has components in the y and also in the x, right? And that is how it works. For every vector that is inclined at an angle, it has components in the y and in the x direction. Now, if a vector is inclined exactly on the x-plane, for example, the first vector here, which has a magnitude of 80 newtons, you can see that the arrow is exactly lying on the x-plane. It means that this vector does not have a component in the y direction. It doesn't have any component in the y. Why? Because it lies exactly on the x-plane or on the x-axis. Do you understand? So that's how it works. And let's suppose right now we had let's say we had a vector here on the y-plane or on the y-axis, exactly lying on the y-axis. That vector will have no component in the x. But if it is at an angle, right? If it is not either on the y or x-axis, it's going to have components in the x and y respectively. Now, how do we resolve vectors into their x and y components? So for the y, we use sine theta, okay? While for the x, we use cos theta. It's a rule. I don't want to start going into SOHCAHTOA right now, but if you want to resolve vectors into the x and y components respectively, we use sine theta for the y component and we use cos theta for the x component. That is how it works. Now let's do that together. First of all, you have to draw a box where you're going to represent all your vectors. Let me do that right here. So here we have a box. And this is where we're going to do all our calculations. This is the first one. This is the second. Here is the third and fourth. Okay. Then I'm also going to draw a vertical line for the forces and another line for the x and the y components. All right. Now let's solve this problem together. This part here, let me clean this y so that we can see what I'm doing properly. Okay. Now, for this one right here, we have our force. And next up, we have the x component. Then we have our y component. So this simply means that when we solve, like we try to break them down, whatever we get for the x component, we write it in this first, okay, box, in the second box rather. Then for the y component, whatever we get, we write it down here. So this is the first force. The first one is 80 newtons. The second force is, we have it here as 100 newtons. 100 newtons. The third one is 110, which is this. We say 110 newtons. And lastly, the fourth one is 160 newtons. To resolve them into their respective x and y components, we're going to do it this way. So we're going to say, for the x component of the first force, remember that this is the first one here, which is inclined exactly on the x-axis. We're going to say 80 cos 0. Okay? Now, why am I saying cos 0? Because from here, this is 0 degrees. From 0 all the way to this part is 90 degrees. And from here all the way to this place is 180. From here all the way again to this place is 270. And lastly, this one is 360. Okay, so a total revolution is 360. Now, you just have to get just add 90. Okay, so from here to here is 90. 90 plus 90 gives you 180. 180 plus 90 gives you 270. And 270 plus 90 gives you 360. And then you start all over again. So this vector is inclined at an angle 0. Okay, so that's the angle of the vector. So that's why we say cos 0 degrees. So we say 80 is supposed to be an 80 Newton, but I think I omitted the n. So 80 cos 0 is equal to, we don't know, but let's go ahead and fill in the boxes before we can calculate. All right, now we have 80 cos 0, right? That's for the x component. Now for the y component, we say 80 Newton sine 0 as well. Okay, so we don't know what the value is, but we shall do that when we're done filling in the boxes. Now for the next one, how do you now calculate? We start from the origin. This is very crucial when it comes to measuring angles of vectors. You have to begin from here. Start from here, from the origin, and go until it touches the vector. Okay, now here is the trick. If the angle is before the vector, you have to add. But if the angle is after the vector, you're going to subtract. Do not forget this. I repeat, if the angle is before the vector, right? If you look closely right here, you discover that this 45 degrees is before this vector. The vector is this line here with an arrow. If it's before the vector, you add. If it's after the vector, you have to subtract. When I mean after, I mean, let's assume that the 45 degrees were here. Then it's after the vector, then you have to subtract. So now we say 0 plus 45 gives us a 45. It means that the true angle of this vector is 45 degrees. Now we say 100, this is now for the x component of the vector. We say 100 newtons cos 45 degrees. Okay, I'm gonna punch that on my calculator afterwards so that we can get their values. Now we have done for the x component. Now let's do for the y component. Again, we say for the y component, we say 100 sine 45 degrees. Okay, sine 45 degrees. This is equal to, we don't know yet. Now let's go over to the third vector. Like I said, always measure from the origin. This is the origin and you're going anti-clockwise. You're going this way. Okay? You are not going this way, please. Okay? Don't go clockwise. Go anti-clockwise. So you have to measure again from the origin. Then you go all the way until it touches the vector. Now, why is it so? If you look closely here, based on this quadrant, right? This is 0 degrees and the first quadrant ends at 90 degrees. Now, what is 30 degrees doing here? This 30 degrees is not supposed to be here because 30 degrees is only found in the first quadrant. Now, if you say that the angle of this vector is 30 degrees, then you're wrong because 30 degrees cannot be found in the second quadrant because the second quadrant has angles between 90 to 180, which means that this 30 degrees is just a reference angle. It is not the true angle of this vector. But now let's check based on our analysis to know whether we're going to add or to subtract. Now we have measured from the origin all till it touches this vector. Now we ask ourselves, is the angle before or after? If it's before, it means it should be somewhere here. Because this is the vector. But if it is after, then it should be around here. So we have seen that this angle is after the vector, therefore we have to subtract. And how do we get the true angle? We say 180 minus 30 gives us all this angle here. Okay, So 180 minus 30 is going to give us 150. It means that the true angle of this vector, which is 110 Newton or newtons, is 150. Like I said, measure from the origin until it touches the vector. If the angle is before, you add. If the angle is after, you have to subtract to get the true angle of the vector. Why? Because this angle here is just a reference angle, and 30 degrees cannot be found in the second quadrant. It's always found in the first quadrant. So now we've discovered that, or we have determined that the angle of this vector here is 150. So we say 150 for the x component cos 150 newtons. Sorry, I made a mistake. So it's supposed to be 110 newtons cos 150 degrees. Okay, now that is for the x component of our third vector. And now let's write for the y component. We say 110 newtons sine 150 degrees is equal to, good. Now the next thing that we're going to do is to calculate the angle for the last vector, which is 160 newtons. We are also going to use the same method again to determine the angle, because 20 degrees, as you have seen, is only found in the first quadrant. You can't have 20 degrees in the third quadrant. Why? Because the third quadrant has angles between 180 to 270. So 20 degrees is not supposed to be here. This means that it's just a reference angle. Now let's check if we're going to subtract or add. Now we start again from the origin and we go this way, all until it touches the vector. Now we ask ourselves, is the angle before the vector or after the vector? If it's before, we add. If it's after, we subtract. Okay, now we've seen that this angle is before the vector. Okay, it's before the vector. It's not here. If it were here, then we say it's after the vector. But if it's here, we say it's before the vector. Now we're going to add. So to get the true angle of this vector, we say from here all the way to this place is 90. Then from here again, all the way to this place is 90, that's 180. So now 180 plus 20 gives us what? 200, which means that the true angle of the last vector is 200 degrees, not 20 degrees, okay? You have to take note of how to measure these angles. If the angle is before the vector, you have to add. If it's after the vector, you surely have to subtract. Suppose this angle were here. If it were here, to get the true angle of this vector, we're going to say 270 minus that angle here, and that gives us the whole angle of this vector. But since we've determined that the angle of the last vector is 200, let's quickly represent it here. Therefore, we say I've made the same mistake again. It's 160 newtons cos 200, that is for the x component, degrees. This is equal to, we don't know yet. And then for the y component, we say 160 sine 200 degrees. This is equal to, we don't know yet. Okay, good. So now we have to get the values and then know what next to do with them. Let me use my calculator. So 80, just make sure you have a scientific calculator to make your job easier. So we say 80 cos 0. If you punch it on your calculator, you will get 80 newtons. And then 80 sine 0 gives you 0 newtons. And next up, 100 newtons cos 45. 100 cos 45, it gives me 70.71 newtons. So we say 70.71 newtons. And then next up, 100 sine 45 gives me 100 sine 45. It also gives me 70.71 newtons. So I will say 70.71 newtons. Now let's do for the next force. The next vector here is 110 cos 150. We say 110 cos 150 degrees. It gives me negative 95.26. So I have negative 95.26 newtons. That is for the x component of the third vector. And for the y component, we have 110 sine 150. I'm getting a 55 newtons. And lastly, for the last one, we have our vector to be 160 newtons. So we say 160 cos 200. I'm getting negative 150.35. So we have negative 150.35 newtons. And lastly, for the y component, which is a sine, we say 160 sine 200. And this gives me negative 54.72. We have negative 54.72 newtons. All right, 72 newtons. Let me cross-check this one to check if I'm correct on that. So 100 cos 45. All right, the answer is correct. Okay, now let's go ahead and add them. You need to understand that all these forces gives you, all these vectors, they give you a resultant vector. That's one thing that you need to know. So we have our Rx. Okay, this Rx means the resultant, the component of the resultant vector in the x direction. It's going to be gotten by adding all the x components together. So the whole x component of all forces gives you the x component of your resultant vector. And all y components gives you the y component of your resultant vector. Okay, your resultant vector also has components in the y and in the x direction. But how is it gotten? In this case, it is gotten by adding them together. Please note, you are to add the x's together and the y's together. Don't mix things up. Don't add x and y together, please. All the x, they go at one place or to one place, and all the y, you also put them together. Don't mix x and y, please. So we say that our Rx is equal to, now we're going to add all our x components together. This is equal to, the first one there is 80 newtons plus, the next one is 70.71 newtons. The third one is plus negative 95.26 newtons. And then lastly, plus negative 150.35 newtons. So this is our Rx. Now, let me add them together so that we can get the resultant vector in the x component of the resultant vector. So I will say our Rx, or R sub x, is equal to, so let me pick up my calculator. We have 80 plus 70.71, and then minus 95.26 minus 150.35. I'm getting negative 95. All right, so this is going to be negative 95 newtons. This implies that the x component of our resultant vector is negative 95 newtons. Now let's work out the y component of our resultant vector using the same method. Now I would say my Ry, R sub y, is equal to, adding them together, the first vector there is 0, or the first value there is 0. So I would say 0 newtons plus The next one is 70.71 newtons, followed by 55 newtons, and lastly we have plus negative 54.72 newtons. Now let's add them together to see what we shall obtain. So our r sub y is equal to, here we have a 0 plus 70.71, and the next one is plus 55 minus 54.72. What are we getting? We're getting 71. So we have 71 newtons. Okay, good. Now we have found our x component and y component of our resultant vector. What do we now do with this information? Remember they said we should find the magnitude, right? Now we're going to find the magnitude right now using a formula I'm going to show you. So since our Rx, let me write it properly, our R sub x is equal to, we got negative 95 newtons, we have negative 95 newtons, and then our R sub y is equal to 71 newtons. Now we're going to find the magnitude. The magnitude of a vector or of a resultant vector is giving us the absolute value is equal to the square root, okay, of Rx all squared plus Ry all squared. So this is the formula to finding, or used to find the resultant vector, okay, or the magnitude of the resultant vector rather. So when we say the magnitude, it's only going to be a positive value. You can't have your r, your resultant vector, the magnitude to be a negative value. No, it's not going to be. If you get a negative value, then you have to evaluate your work to check if you're correct or not, okay, and then you have to correct your mistake. So it has to be a positive value always. Then we're going to fill in what's our Rx. Our Rx is negative 95. So here we're going to put the negative 95 here, and here we put a 71. Then we take the square root and see what we're going to get. So let's do just that. This is equal to the square root. Our Rx is negative 95 all squared plus our Ry is 71 all squared. Now let me write them here to see what we're going to obtain. This is equal to, okay, so 95 squared or negative 95 squared is equal to 9025. We have 9025 plus, remember that this is a negative number being raised to the power of an even number. Okay, so an even number is the power. Eventually the negatives are going to cancel out, just like when you have negative 95 times negative 95, that's equivalent to raising it to the power of 2. So these negatives are going to cancel out and you end up with a positive value. The next one is 71. So 71 squared is equal to 5041. We have 5041. Now let's add them up and take the square root. 9025 plus 5041, it gives me a 14066. We have the square root of 14066. Therefore, the magnitude of the resultant vector is equal to, let's take the square root, 14066. So the answer is 118. We have 118.6 newtons. This is the magnitude of our resultant vector. Okay, now we have found the magnitude. The next thing that we're going to do right now is to find the direction. How do we find the direction? The direction is given by the formula tan theta is equal to ry all over rx. Okay, you must always use a tangent. We use a tangent function to get the direction of a vector. So we're now going to say, to solve for theta, theta is now going to be tan inverse ry all over rx. Now, what's our ry? We got our ry to be 71. So we say our theta is equal to tan inverse of 71 all over. Now, the next one is negative 95. So we say this is going to be negative 95. Why am I including the negative? Because I want to get a true angle. Some would say ignore the negatives, but it's also good to ignore the negative, or sometimes you might forget. This negative tells you the actual direction so that you make no mistake, right? I'm going to explain that when it's time for me to sketch it. Good. So now we say, let's now punch it on our calculator to see what we're going to obtain. So we have shift tan, and we have 71, okay, over 95. I'm getting negative 36.8 degrees. So our theta is equal to negative 36.8 degrees. Good. Now, this is our solution. This is the angle, right? And then, what do I mean by the answer, or that the angle, or by the angle is negative 36.8? Let me explain to you properly so that you really understand what is happening here. Because with this angle now, we can go ahead to sketch our resultant vector. Now, please look at this very closely. This is an XY plane. I want you to pay attention as we go through this direction so that you see how it works. Now, this is your first quadrant. Here, you have your second quadrant. This is your third quadrant. And lastly, this is your fourth quadrant. For the first quadrant, the x and the y are positive. Do you understand? The x and y are both positive values. So if your resultant vector has a y component that is a plus and an x component that is also a plus, it means that the angle will fall in the first quadrant. Now, for the second quadrant, the x-axis is a negative, but the y is a plus. It's a positive. Now, if the y component of your resultant vector, or of any vector, is a plus and the x is a minus, it means that the angle will fall in the second quadrant. I hope you understand how this works now. So you have to pay attention to the signs that accompanies the values of the x and y. Here, our x component of the resultant vector has this very value, and it's a negative 95. This means that this angle is going to fall somewhere along the negative x-axis. And then the y is a positive value. It means that since the x is a negative and the y is a positive, the direction would be in the second quadrant, because y is a plus and x is a minus. In the same way, here is the negative y. If your x component of your vector is a plus and your y component is negative, the angle is going to fall here. So you must pay attention to those signs in order not to get confused. Now, since we got this to be in the second quadrant, we can go ahead and sketch it. But before we sketch it, which is the resultant, we can get the actual value, okay, of the angle. So we can say, since this is the first quadrant, and here is the second quadrant. Remember that this is just a reference angle, right? Now we say this is the sketch. This looks too long. The arms are very long. It's going to fall in the second quadrant. Remember that the x is negative and the y is a positive. So I'm going to draw or sketch this way. And what's the resultant? The resultant we got was 118.6 newtons. Okay, good. Now, this angle is going to fall here. Like, this is going to be the angle. Let's say 36.8. This is the angle. Now, why is this so? It's because suppose you want to get the actual angle of this, you have to measure from here, right? From the origin. And then you go this way until it touches the vector. Then you ask yourself, is this angle before or after the vector? If it's here, you have to add. But if it's after the vector, you're going to subtract. Hence, this negative sign here. So since it is after the vector, we always have to subtract. Now, look at this. This is the first quadrant, which is 90. This here is 180. So now to get the actual angle of this vector, we're going to say 180 degrees minus 36.8 degrees. So what do we get? We have that our theta is equal to 180 minus 36.8. It gives me 143.2 degrees. Hence we have 143.2 degrees. This is a true angle of this very vector. But if you're sketching it, it has to appear this way. Okay? It has to appear this way. This is how to sketch it. Because you can't say you're writing 143 degrees. No. These are just reference angles, and we use reference angles to sketch vectors. Okay? I hope you understood everything I explained in this video. If you have any questions, comments, or concerns, you can reach out to me in the comment section, and I'll be right there waiting for you. Thank you for being there, and see you in the next video.